Just give you a few tips for working through this problem set in a more efficient manner. So when I want to start with a super simple example. Let's say that I just had 2x set equal to 4. You would solve this by multiplying both sides by 1/2 or dividing by 2 to isolate the x. And then you would arrive at x equals 2. When you've got a factor times something in parentheses set equal to, so I'm modeling this off of this problem right here. When I have something that's this clean, it doesn't matter what's inside the parentheses. It doesn't matter what it is. You can always start this equation by multiplying by 1/2. And then what you're left with is whatever's inside parentheses set equal to 2. You do have the choice to distribute through, but the problem set, this particular problem set, is designed to start thinking in that reverse mode to make things a little bit more simpler. There's nothing wrong with the distributive property, but on the way to solving some of these systems, it's actually more efficient to divide that number out first. So let's analyze a few of these together in an effort to get your work to be just a little bit more efficient. So looking at something like problem set A, if I were to divide by 2 on both sides in this first equation, or multiply by 1/2, then I would turn the first equation into x minus y equaling 4, and then I'll box in red my system. So for solving systems of equations, now this becomes much more efficient than distributing that 2 through to that first, into the x minus y. And let's look at the next problem on down. Here, if I simply divide it by 3, I would have 2a plus b being set equal to 0. And I could actually now easily turn this into a substitution problem by solving for b here. So b would be negative 2a. That's just one alternative. I'm just trying to get you to start analyzing these in a little bit more sophisticated, efficient way in order to cut down on your workload as well as cut down on your chance for errors. So let's look at something like A right here. If I distribute 1/3 through this problem, then I end up with a fraction in the problem, which is fine, but if I can avoid it, I should. So I could multiply both sides by the reciprocal, and I could turn this first equation into 2x plus y equaling 3. And then this becomes the system that I can solve either by substitution or elimination. It's completely up to you at this point. And let's look at the next system down. I'll move the screen up. And the next system, it would be most efficient if I could multiply by 2 over 1 and turn this first equation into m minus 3n being set equal to 10. And then looking at the second equation, if I multiply by 1/3, then I'm going to have m plus 4n being set equal to negative 4. And then this becomes the system that I can solve either by elimination or by substitution. So I'm just trying to give you ways to analyze these problems so that you can start to work in a more efficient way. And looking at problem set F, we could use our trick of multiplying each term by the common denominator over 1, and that would mean everybody would have to pick that factor up, but it makes it a much nicer problem. So I would end up with 2x plus 3y being set equal to negative 24, and then this is the system that I would end up solving. So I just wanted to give you a few tips or hints on how to get through this in a more efficient manner so that you can start to work quicker and with more accuracy.